Hello, and welcome back to another exciting episode of the fourth programming language. Again, working out of the book, starting fourth. Last time we did some math functions, and I showed you more about the stack. And we started with swap, which allows you to do stack manipulation. I mentioned other stack manipulation operators or words operators, and we're going to cover those. Now, I'm going to put stuff on the stack and show you what comes off the stack. So I'm going to start doing it this way. 3, 2, 1. And to show you what comes off the stack. And again, remember when you do the dot, it pulls up whatever's on the top of the stack, pulls it off and displays it. So it does 1, 2, 3. So we put 3, 2, 1 on, 3 got put on top, then 2 got put on top of 3, then 1 got put on top of 2. So when we pulled it off, 1 was on top, so we pulled it off, displayed it. Then the next one was 2, and then 3. Now our stack is empty. All right. So again, I'm going to cover swap now. I'm going to show you again. Put 3, 2, 1 on the stack, and then we're going to swap. Then I'm going to show you what's on the stack now. There you are. As you see, it took 1 and 2 and swapped them. Because they were on top of the stack. Now, you have nothing on the stack. I'm going to load it up again. And now we're going to do the dupe. I'm going to show you 3 of them, but actually there's 4 of them. The reason why is because dupe duplicates the top stack item. See, the top stack item was the number 1 because it was last on. So it's at the top of the stack. So I duplicated it just to show you 3 is still there. Now our stack is empty. So we had 3 on the stack, 2 went on top of 3, 1 went on top of 2. We said dupe. So it duplicated what it found on the top, which was 1. So now we had, and it put it on the stack. So we had 1, 1, 2, and 3. All right. Now we're going to do over, which makes a copy of the second item and pushes it on the top. So again, here we load up our stack. 3, 2, 1. And we're going to say over. And again, I'll show you what the stack looks like. So it took the middle one, duplicated it, and put it on top. Again, 3 is still there. See? So 3, 2, 1 with over became 2, 1, 2, 3 as we pulled it off the stack. So it took the middle one, makes a copy of the second one, pushed it on top of the stack, which in this case was 2. It made a copy of number 2, put it on top of the stack. Now we have what's called rot, which is rotate. They actually call it rote, but they did not put the E at the end. I personally wish they had put the E at the end. But let's load up our stack again. All right. Now we're going to do rotate, call it rot, and I'll show you what it does. Okay. Rotated the third item to the top. As you see up here, when we put it on the stack, we had 3, 2, 1 normally. And as these dots pull them off the stack, 1 was on top, so it's gone now. Then it had 2, then it had 3. What this did was took this third one and pulled it out and put it on the top of the stack. So 3 became the top, then 1 and 2. Okay. Now again, these don't make a lot of sense. You don't know how you use them right now, but eventually you will end up using them, which is why you need to know the stack manipulation. And the next one is drop. I'll load up the stack again. And drop just basically drops what's on top of the stack. Now, I'm going to end up with an error here because it took what was on top of the stack out. So we're now down to 2 items. See, we got rid of the one that was at the top of the stack. We had 2 and 3 right there, 2 and 3, and we ended up with stack underflow. Now let me show that to you again without the error. So what it does, we have 3 at the bottom of the stack, 2 in the middle, 1 at the top. We said drop, so it just basically pulled off the top of the stack without displaying or anything else. All right, there you are. And apologize for my allergies. All right. Now, why do you want to use these? Well, let's actually start with like the dupe. Um, let's put 2 on top of the stack. All right. Now, let's say we wanted to square that number, which is 2 times 2. Well, we could put another 2 on here, and we can do the multiply, and then we can describe our answer, which is this. Right? Let's change it up here. Let's do 2, 3, well, 2 times 2, or 3 times 3, whatever it is, squared. Okay, so we're going to do the square function. Well, we know what our number is. If we say dupe, I know it's longer. Don't worry about that. We've just duplicated it, and then we can display the result. Now, that's right. But see, the other 2 is there too. So if we do 2 dupe asterisk, we've now done the multiplication. 2 times 2. Right? So that's what we do. That's an example of what dupe can do. Now over, they use an example of A times A plus B. And you have A and B on the stack. And this is going to confuse you. Just don't worry about it. We're going to put 3 on the stack, 2 on the stack. All right. But what we're going to do is we're going to duplicate the 3. All right. So we can do A times parentheses A plus B. So 3's on the stack. We're going to do 3 times 3 plus 2. Okay. So we can then take the 3, put it over, and then we can add the 2 numbers on the top, which is 2 plus 3. And then we can take that result times and get our answer. I'm not liking this, but it does work. Trying to tell you the logic of stacks and over, but you see I can do it. There's other ways you can do it. Um, and then rotation. Again, best way is to follow the example in the book. We've done this before. That's all right. I'm just going to skip over that because again, these can start confusing you, but you do need to know what these functions are. And then again, drop makes complete sense. You just want to get rid of something on there that you don't need. Just discards the top of the stack. All right. Drop is probably a lot of the most helpful thing. Now, before we were doing a print, and it's a destructive print, right? And now there's nothing on the stack. Can we print this thing without destroying the items on the stack? And the answer is yes. Non-destructive. So we don't have anything on the stack right now, so we can do S. It says we're at the top and there's nothing there. Okay. We'll then put a 3, 2, 1, and let's do it again. It shows you what's at the top. So 1's at the top, then 2, and then 3. All right. So we can literally do it. And by the way, they're still on there. Let me just show you. There's 1, 2, and 3. So from now on out, like up here before when I was doing those, I could do 3, 2, 1. Show you what's on the stack. I'm going to go try capital S, see if it did any different. It doesn't. Okay, so it shows you 3, 2, 1 are on the top. With the top one, number 1 is actually on the top, and it displays what's on the top. So now I can do over. So it took that. Now I can show you what's on the stack. All right, and that's where this comes in handy now. We do stuff like this. And we can return back by saying drop. See, that's where drop comes in handy. And now you get the idea. So from now on out, when I do the .s, it'll show you what's on the stack without destroying it. It's a .s, but I like calling it stack, .stack, because it'll show you the stack without deleting it. And I think this is good enough right now for today. I know this is episode, what is it, 6, 7, whatever it is, 7, 6. And I still haven't showed you how to actually program. I'm just showing you the basic functions of Forth, which is good. You need to know these before you start programming. You need to find out how it operates, which is very good. And hopefully I can remember our .s in our functions so that we can continue on. So that's it for today. Again, we did our swap, which we've done before, dupe, over, rotation, rot, and drop. And how to display what's on the stack without destroying what's on the stack. .s. All right. Thank you. Have a good one. Bye.